Okay, so here we go with 6.5, graphing rational functions. We have been talking about rational expressions and rational equations. Now we're calling them functions because we're actually going to put them on a graph and graph them. So a rational function is a function of the form f of x equals p of x divided by q of x. Okay, because we know a rational is just one polynomial divided by another polynomial. We talked about that back in the first lesson of this unit. A rational just means one polynomial divided by another polynomial, a monomial, binomial, trinomial, whatever it is. They're polynomials, okay? So p of x and q of x are polynomials. And q of x cannot be 0 because we know we can't divide by 0. All right, so to be able to find all of the things that we need to find, the x-intercepts, the y-intercepts, the asymptotes, and the holes, we've got to go through this process. So let's talk through these real quick, and then we'll get to where we're going to actually do some of them. So the first thing we need to do is simplify the function. If there's anything that can be factored and canceled, we need to do that. Okay? So if there's anything to be factored and canceled, that's step number 1. Step number 2 is to find the x-intercepts by setting the numerator equal to 0. Okay, and my answer is going to look like this. My answer is going to look like whatever the x is, comma 0. It's going to be a point. I'm not going to write x equals because that's going to look like the vertical asymptote. Then we're going to find the y-intercepts by setting x equal to 0 in my simplified function. So if I factored and canceled and simplified it, that's the one I'm going to use when I go back to find my y-intercept. And my answer is going to look like this, 0, comma y. Then we're going to find the vertical asymptotes by setting the denominator equal to 0. And vertical asymptotes, remember, are always in the form x equals. Okay, so my vertical asymptote is going to say x equals something if it has one at all. I've said down here on the bottom, the graph will never cross the vertical asymptote, and there can be more than one. Okay, which is really weird, but it happens. There can be more than one vertical asymptote. Okay, now horizontal asymptotes are kind of different because horizontal asymptotes have 3 different cases, right? Horizontal asymptotes have 3 different cases. And it looks like what we're comparing is the degree. The degree of P, which is the degree of the top, compared to the degree of the bottom. Well, what are we talking about when we're talking about the degree? Well, let me flip over here. You guys don't have to flip with me. I'm just going to show you. When we're looking at number 7 and we're talking about the degree right here, the degree is the biggest exponent. So like, what's the degree of the top right here in number 7? 3, okay? And what's the degree of the bottom? A 2. So are we bigger on top or are we bigger on bottom right here? We're bigger on top because 3 is bigger than 2, okay? So what we're comparing are that degree. We're either bigger on top, we're bigger on bottom, or we're they're the same. So that's your 3 different cases. You're either bigger on bottom, bigger on top, or they're the same. Okay, so I'm going to put over here for degree, this means look at exponent. Okay, so for the degree, that means you're looking at the exponent. You're looking at like x to the third over x squared. You're looking at this exponent. Now, we have this silly mnemonic that we math teachers like to use. And it's funny, I had a student in here yesterday that has already taken pre-calc and she's moved on to further math classes from there. But she was in here yesterday and I said, oh, I'm teaching Bobo Botten Eats DC today. And she was like, oh, I remember Bobo Botten Eats DC. And that was 2 years ago. Okay. So it's a really silly mnemonic, but it's really helpful and helps you remember what you're supposed to do here. So it sounds like a robot eating our capital, Bobo Botten Eats DC. But that's not what it is. It's a silly mnemonic for how to remember the 3 different cases for horizontal asymptotes. So this is what we're doing. If the exponent is bigger on bottom, okay, we call that Bobo. And it means that our asymptote, our horizontal asymptote, is at y equals 0, which that's just our x-axis. Okay? Bobo, y equals 0. Okay? Remember, our horizontal and slant asymptotes are always going to be in the form y equals. If we're bigger on top, like this guy right here, this one is a bigger on top example, then there is no horizontal asymptote. So that's our bottom. Bigger on top, none. No horizontal asymptote. Yay. That's an easy one. But there's a but after that. We'll come back to that in just a second. Okay? Now, if they're the same, if the degrees are the same, the degree of the top and the degree of the bottom are the same, that's our EATS. Exponents are the same. Divide coefficients. We're going to have to divide the leading coefficients. So like right here, the leading coefficients are the number out in the front. So for this one, it would be y equals 1 over 1, which is just 1. So it's y equals leading coefficient of p of x divided by the leading coefficient of q of x. The leading coefficient of p of x divided by the leading coefficient of q of x. So y equals whatever this is. Okay. Now, one little stipulation to when there's no horizontal asymptote. If there is no horizontal asymptote, that means there could be what we call a slant asymptote. Okay? It's a line with a slope. You know, it's slanted like this, a slant line, a slant asymptote. But guys, slant asymptotes happen in very specific cases. If the top is exactly 1 degree more than the bottom, exactly 1, not 2, not 3, not 5. If it's exactly 1 degree more than the bottom and it's not already linear, there could be a slant asymptote. And we're going to find them by using long division. Okay? And we'll do some of that together on Friday. So when we do find a slant asymptote, they're going to be like a line. Okay? This is like y equals mx plus b. It's just a line. Right? So instead of being x equals for vertical, y equals for horizontal, it could be like a line, y equals mx plus b. So it's still a y equals, but it could be a line with a slope. Okay, so 3 cases for the horizontal asymptote. Bobo, Botten, EATS, DC. The last thing that we need to talk about is a hole. Where do these breaks in the graph happen? So you have to identify if there are any holes in the function. So x comma y, the hole is an actual x comma y point. It's a point on the graph. Here's a little bit of information about the hole. It's called a removable discontinuity. Okay. It's a point at which there's a break in the graph. And when we get to our first one in the notes today, I'm going to go into Desmos and show you how that actually happens. Okay. The graph does not exist at this location. A hole occurs when there's a common factor between the numerator and the denominator that you can cancel out. So at the very beginning, when we simplify, if there's something that we can cancel, that's when there's a hole. If there's nothing that cancels out, there's no hole. So they don't always happen, okay? Only sometimes. And to find the x coordinate of the hole, we just take whatever we canceled out. Like if we cancel out x minus 5 and x minus 5, we take that x minus 5, set it equal to 0. That's how we get the x coordinate. And then we just plug the x back in to get the y. All right? So we'll do some examples here in a little bit where we actually go to find a hole. All right. Let's now go and graph our parent function. Okay? And I'm going to refer back to these steps all the time, and you guys are going to want to refer back to them too. Okay, so we're going to graph the parent function. So it's going to be kind of different, okay? But we're going to follow all the steps exactly as written so that we see what happens on these things every time. So this is the parent function of the rational function, okay? So I'm going to follow my steps. Simplify. Is there anything here that needs to be factored and canceled? Guys see anything that needs to be factored and canceled? I don't see anything, right? Nothing factors. So I'm just going to write sim and do a check mark that I did that step because I don't want to forget that step. To find the x-intercept, we're going to set the numerator equal to 0, right? Don't make this harder than it is. Do exactly what the steps tell you to do. The numerator is a 1, so I'm going to set 1 equal to 0. Now, does that make any sense? Does 1 equal 0? No, never. So this means that there is no x-intercept. So I'm going to write none. Okay? And guys, if there's no x-intercept, if there's no spot where the graph crosses the x-axis, that probably means that there's an asymptote there. So we're going to find that out here in just a minute, but that's probably what that means if there's no x-intercept, that there's an asymptote. Because if there's an asymptote, there can't be an x-intercept on the x-axis. Okay. Y-intercept. To find the y-intercept, set x equal to 0 in my simplified function. So remember, we can always replace f of x with y, okay? So I'm going to write y equals 1 divided by 0, because that's what my steps tell me to do. My steps tell me to replace x with 0. Now, can I divide by 0? No, this is undefined. That also means that there's no y-intercept, which there's a pretty good chance if there's no y-intercept, that means that's going to be an asymptote. But let's find out. Okay, vertical asymptote. My directions say to find the vertical asymptote, we set the denominator equal to 0. What's my denominator? X. So x equals 0. Oh, that's easy. That's my vertical asymptote. X equals 0. Well, I love that because x equals 0 is actually just the y-axis, which we already knew that was happening because there was no y-intercept. So here's my vertical asymptote. You have to draw these because the asymptotes here like shape our graphs. They like tell us where our graphs are going to be. Okay, to find the horizontal asymptote, I look at the exponents. Now, the numerator doesn't even have an x with it. So it's like x to the 0. Okay, it's like 1x to the 0. Guys, because what is anything raised to the 0 power? 1. So this is like 1 times 1, which is just 1. So the numerator is x to the 0. The bottom one is x to the first. We just don't write that 1 in algebra. There's a 1 right there. So looking at the degrees, am I bigger on top or am I bigger on bottom? Is 0 bigger than 1 or is 1 bigger than 0? I'm bigger on bottom, right? Bigger on bottom means 0. So that means y equals 0, which is the x-axis, is my horizontal asymptote. Hurry, Hoyer. Okay. Now, did I factor or cancel anything? No, I did not. So this is a none. End behaviors, domain, and range. I can't tell any of that until I get some of my graph drawn. So I'm going to have to pick some points. No problem here. I'm just going to pick -2, -1, 0, 1, and 2 because those are easy and kind of see what's going on with my graph. So let's plug in -2 for x. If I plug in -2 for x right here, I get 1 over -2, which is -0.5. So -2 and -0.5. I'm down here. All right, let's plug in -1. 1 over -1 is just -1. So this is -1. So -1, -1. So I got to know kind of what these things look like. They're these rounded things. And so this one looks like it's on this side. The asymptotes shape our graph. So we come across, we round at the corner right here, and then we come on down next to the asymptote. So the asymptotes really shape our graph. Okay, 0, I can't divide by 0. So this one's undefined. I should have already known that. I already plugged in 0 right there to check for my y-intercept. Okay, how about 1? 1 divided by 1 is just 1. So over 1, up 1. And 1 over 2 is 1/2. So over 2, up 1/2. This one must do the opposite on the other side and come around like this. And this is what my graph looks like. All right, so for end behaviors, we write out this as x approaches positive infinity and as x approaches negative infinity. We do y approaches. And I don't care if you use y or f of x right here. I'll do it interchangeably today. It doesn't matter to me. All right, so let's look. As my x's are getting bigger and bigger and bigger, what are my y values getting closer and closer and closer to? 0. And they're never going to cross 0 because that's an asymptote. So I'll give you guys a really big hint right now. If there's a horizontal asymptote like this, then that's what the y values are going to approach on both sides. Okay? So wherever that horizontal asymptote is, that is normally where your y values are going to approach in your end behaviors. All right, let's talk about domain. Domain is the span of the x's. So looking from left to right, what x values are included in this graph? Everything but 0. That's exactly right. Everything but 0. I have to jump over that asymptote. So to use interval notation to do that, we're going to say, okay, it's from negative infinity to 0, and then I use a parenthesis so I don't include it, and 0 to positive infinity. So this lets me jump over 0. Just get really, really, really super close to it, but not actually include 0 itself because that's where my asymptote is. So how about my range? What are the y values that exist? Everything but 0. That's right. We've got to jump over that asymptote, that horizontal asymptote. We got to exist right up to it, jump over it, and then exist right on the other side of it and go all the way up to positive infinity. So it's going to look exactly the same. Okay? All right. So let's do one that looks just a little bit different than the parent function. Okay? A little bit different. 1 over x squared. We just had 1 over x. Now we're going to do 1 over x squared. So again, this one looks just a little bit different, but we're going to follow through the steps exactly word for word that we did on the front of the page. First thing is to simplify. Is there anything here that needs to be factored and canceled? You guys see anything that needs to be factored and canceled? I don't see anything. So it's simplified. Step number 2 is to find the x-intercept by setting the numerator equal to 0. The numerator is 1 equals 0. That doesn't make any sense. There must not be an x-intercept, which probably means there's going to be an asymptote on the y-axis. All right, to find the y-intercept, it says to set the denominator equal to 0. To find the y-intercept, we set x equal to 0 in my simplified function. So y equals 1 over 0 squared. Well, 0 squared, it doesn't matter. I can't do this. This is undefined. So there's none. I don't have any intercepts. No x and y intercepts. Probably means those axes are my asymptotes. Let's find out. To find the vertical asymptote, I set the denominator equal to 0. So my denominator is x squared. Set it equal to 0. To solve for x, I can just square root both sides. And I get that my vertical asymptote is at x equals 0, which is just the y-axis. This guy right here. Okay, my horizontal asymptote. This is where I check my 3 cases, my Bobo, Botten, eats DC. Technically, this is 1x to the 0 because there is no x there, over x squared. So am I bigger on top, bigger on bottom? Bigger on bottom again, okay? Bigger on bottom, Bobo. That means y equals 0. The 0, Bobo, the 0, bigger on bottom, 0, means y equals 0. Okay, which is the x-axis, is your horizontal asymptote. This guy right here. We knew that was probably going to happen because there weren't any intercepts. Okay, we'll get to some that have them here in a minute. Okay, I didn't factor and cancel anything, so there's no holes, no removable discontinuities. Again, we'll get to some of those here in a minute too, but still got to go through all the stages just to make sure. Let's do a little bit of graphing. I'm going to plug some points in. Again, I'm just going to pick -2, -1, 0, 1, and 2 because it's easy and it's going to kind of tell me what this thing looks like. When I plug in -2, I'm going to get 1 over -2 squared, which is -2 squared is 4. So this is 1 over 4. So -2 and then 1/4. When I plug in -1, -1 squared is 1. So this is 1 over 1. So -1, 1. So this one must come across down here and go up like this. I can't plug in 0. I already determined that over here. I could have just skipped that one because I already know that's undefined, 1 over 0 squared. But 1 over 1 squared is 1. And 1 over 2 squared is 1 over 4. So 2 and 1/4. This one must come across like this on this other side. So these don't have to be perfect. Our graphs don't have to be perfect. But you can certainly plug in enough points that you can figure out pretty much what the thing's going to look like. Make sure you always graph your asymptotes because your asymptotes really, really shape your graph. Okay. So end behaviors. As x approaches positive infinity and as x approaches negative infinity, f of x approaches, this is the same every time. What's going to change is what goes right here. Okay, and so as my x's are going to positive infinity and negative infinity, what are my y values getting closer and closer to? 0. Okay, so these are zeros. All right, let's talk about domain. Let's talk about the x values that are included in this graph. What are the x values that are included here? Everything but what? Everything but 0. So I need to go negative infinity to 0 and 0 to positive infinity. Okay. And with my range, be careful. What are the y values that are included? Yeah, it's only from 0 to positive infinity. There's nothing in the negatives because I've got a squared down here. So it's only 0 to positive infinity. Good. All right, let's graph. F of x equals x minus 4 over x plus 4. These are both binomials. Is there anything that I can factor and cancel out of them? I don't see anything, okay? I'm going to go ahead and put my table over here, and I'm going to write that I tried to simplify it, and there's nothing to be simplified. And now I'm going to follow through all of my steps to make sure that I do everything I'm supposed to do now to find all the pieces. So the first thing I do is find the x-intercept. To find the x-intercept, my directions say set the numerator equal to 0. So x minus 4 equals 0. Therefore, x equals 4. And to write it as a point, it's 4, 0. So 1, 2, 3, 4. There's my x-intercept. I'm going to go ahead and put it in my table. To find my y-intercept, I set x equal to 0 in the simplified function. So here's my function. Wherever there's an x, I'm going to plug in a 0. It's just like putting a 0 in your table. Plug in zeros for x and see what you get. So y equals 0 minus 4 over 0 plus 4, which is negative 4 over 4, which we know is negative 1. So 0, negative 1 is my y-intercept. So I'm going to get that one on my graph. Okay. Vertical asymptote. Find the vertical asymptote by setting the denominator equal to 0. X plus 4 equals 0. X equals negative 4. There's my vertical asymptote. It's in the form x equals, and it's at negative 4. So I'm going to come back here to negative 4. I'm going to do a dashed line. I have to graph my asymptotes on these because they shape my graph. I don't know what the graph's going to look like without my asymptotes. Okay, horizontal asymptote. This is where I need to look at my exponents. So remember, this is x to the first, and this is x to the first. So am I bigger on top, bigger on bottom, or the same? I'm the same. So exponents are the same. Divide coefficients. Okay, the coefficients are the numbers out in the front. So what's in front of this x to the first? A 1, and this one's a 1. So it's y equals 1 over 1, which is 1. So y equals 1 is my horizontal asymptote. Okay, my graph's come into a little bit of shape here. I did not factor and cancel anything, so there are no holes. We'll get to one here in a minute where there's holes. Okay, so I can't do the rest of these things until I have my graph. So I can kind of see what this one's going to do. I might plug in like -1, -2. I might plug in like -3 and just see what happens. So like -3 minus 4. What's -3 minus 4? -7. Okay. And what's -3 plus 4? 1. -3 plus 4 is 1. So this is -7. So -3, 1, 2, 3, -7, 1, 2, 3, 4, 5, 6, 7. Now I can really tell what this looks like. It comes across and goes like this. Okay. But the problem is I don't know where the other side of this is. There's usually 2 of these, and I don't know where the other one is. So to find the other one, I'm going to have to plug some more x values in. I think it's back here somewhere. So I'm going to have to plug some x values in that are back here and see if I can find where the other half of this thing is. Because it might be down here, but it might be up here, and I'm not sure. So I'm just going to plug in, I'm going to try -6, okay? I don't want to do -4 because that's my asymptote. I'm just going to jump to -6 and see what's happening. So -6 minus 4 is -10 over -6 plus 4 is -2. And what's -10 over -2? That's +5. So -6, 5. So it must be up here. Let's plug in -8. -8 minus 4 is -12. -8 plus 4 is -4, which means that one's at 3. So -8 is up at 1, 2, 3. So I can kind of see what this looks like now. It's going to come across on this other side like this. So I just picked some points that were on this other side for my x values so that I could figure out what the y values are and figure out where the other half of my graph is. End behaviors are actually really easy, especially when there's a horizontal asymptote. As my x's are approaching positive infinity and x's are approaching negative infinity, f of x approaches, so what's it approaching on both ends? What are my y's getting closer and closer to on both ends? The 1. It's always going to be the horizontal asymptote right there, you guys, 99.9% of the time. Okay, domain is the span of the x's. So what are the x values that are included in this graph? Looks like this one goes back to negative infinity and this one goes to positive infinity. All of them but what? All of them but -4 because I got to jump over that asymptote. Okay, so negative infinity to -4 and -4 to positive infinity. Okay, how about my range? Everything but 1, okay? So negative infinity to 1 and 1 to positive infinity. Okay? All right, let's work on this guy. Is there anything that can be factored and canceled here? If you take a 2, okay, we could try to take a 2 out of the top right here. 2 times x minus 3 over x minus 1. Does it let anything cancel, though? It really doesn't. So if it doesn't let anything cancel, you really just want to stick to your original one, okay? Because it's easier that way if nothing cancels, right? So I'm going to put simplified, check, done. Let me get my table over here. and go through my process now of finding all of my things. Okay, to find the x-intercept, I set the numerator equal to 0. So 2x minus 6 equals 0. Solve for x. So 3, comma 0 is my x-intercept. 1, 2, 3. I'm going to go ahead and stick it in my table there. So when I go to find some points, I don't accidentally try to check 3 again. I've already found that one. All right, to find my y-intercept, I plug 0 in for the x's. So it's basically like I'm plugging 0 into my table right here. And I'm going to plug in and find where my y-intercept is. So I'm going to replace f of x with y and just write y equals 2 times 0 minus 6 over 0 minus 1. Everywhere there's an x, I'm going to replace it with a 0. This is 0 minus 6, which is negative 6 over negative 1, which we know is positive 6. So 0, 6 is our y-intercept. 1, 2, 3, 4, 5, 6. Okay, find the vertical asymptote by setting the denominator equal to 0. X minus 1 equals 0. X equals 1. There's my vertical asymptote. Got to graph the asymptotes. They really shape these graphs. So without them, it's hard to know what the graph's going to look like. Okay, horizontal or slant asymptote, we're going to check our exponents. This is x to the first. This is x to the first. Are we bigger on top, bigger on bottom, or the same? The same. Exponents are the same. Divide coefficients. So y equals, what's the coefficient on top? The number out in the front. 2. What's the coefficient on the bottom? A 1. Okay, right there, 1. And 2 divided by 1 is 2. So y equals 2 is my horizontal asymptote. There's no holes. I didn't factor and cancel anything. Okay, I maybe need just a little bit more here. Maybe I'll try I don't know. Maybe we'll plug in 6. Just to see kind of what's happening over here. So 2 times 6 would be 12 minus 6 would be 6 over 6 minus 1 is 5. 6 over 5 is 1 and 1/5. So over 6, 1, 2, 3, 4, 5, 6, up 1 and 1/5, right there. So I can see it's going to come across and around like this. Back here, I don't know. Let's plug in -3 just to see what happens, because I need something over in this way to get just a little bit, figure out where it goes around to my asymptote. So let's try -3. So -3 times 2 is -6, minus 6 is -12, over -3 minus 1 is -4, so that's 3. So -3, 1, 2, 3, 1, 2, 3. There we go. All right, in behaviors, as x approaches positive infinity and negative infinity, f of x is approaching. Okay, what's it approaching both times? The y values are getting closer and closer to that horizontal asymptote. Okay, domain, everything but what? Good. Negative infinity to 1. Range, everything but what? 2. Skip the asymptote. Awesome. All right. On this one, step number 1 is to simplify. Do you guys see something that needs to be simplified here? I do. That top, right? X squared minus 1 factors into what?
X minus 1, x plus 1.
Yes, x minus 1 and x plus 1 over x minus 1. Okay? So does something cancel now? Okay, ding, ding, ding. That's when you're going to get a hole. If you are able to factor and you're able to cancel something, we are going to have a hole. That's why none of the other ones did yet, because we didn't do that with anything else yet. Okay, the x plus 1 is left in the numerator. So my simplified function is now f of x equals x plus 1. I like to do it. I like to bubble it and highlight it so that that's what I look back and focus on as I move through all these steps. Use your simplified function because it makes life so much easier as you move through the steps. Okay. X-intercept. To find the x-intercept, you set the numerator equal to 0. Well, my numerator in my simplified function, this is the x plus 1. It is in the numerator. Remember, it's just a 1 now in the denominator. Okay, so this is my numerator. So to find my x-intercepts, x plus 1, set the numerator equal to 0. So my x-intercept is at negative 1. Do I better get me a table over here so I can see my points that are happening? Negative 1. 0. There's my x-intercept. Hey, quick question. What's this going to graph? Y equals x plus 1. What's this going to graph, you guys? It's just a line. This is just linear. Okay? We took away all the craziness and we're left with y equals x plus 1, which is just a line. But it's going to be a line with a hole in it. It has a hole. It has a hole in it. This right here makes it be a hole. So it's going to be a line with a hole in it. Okay, so x-intercept. Sorry, I should have said that before I started x-intercept. Okay, y-intercept. To find the y-intercept, I replace the x with a 0. So y equals 0 plus 1. That's just 1. So 0, 1 is my y-intercept. Which I already knew that because that's y equals mx plus b. That's the b. Your 1 right there is your y-intercept. I already knew that. To find the vertical asymptote, I set the denominator equal to 0. What is my denominator? A 1. 1 equal to 0. Does that make any sense? No, there's none. Horizontal or slant asymptote. Okay, it doesn't matter if you look at this, the simplified one or the original one. You're going to get the same conclusion. So if you just glance back real quick at the original, am I bigger on top, bigger on bottom? Bigger on top, right? The 2 is bigger than the 1. Bigger on top? None. That means there is no horizontal asymptote, but that means we have to check for a slant asymptote. Now let's read the directions on the front of the page here. Bigger on top, none. Okay, read this right here. If the top degree is 1 more than the bottom, and is that the case? Is the top exactly 1 bigger than the bottom? Yes. And it's not already linear. Uh-oh. Am I already linear here? Okay, so there's also no slant asymptote because we're already linear. No asymptotes. No asymptotes at all on this guy. But there's going to be a hole. Okay, there's going to be a hole. How do I find the hole? Well, I'm going to follow my directions. To find the x-coordinate of the hole, set the common factor that you canceled out equal to 0. So what did we cancel out? X minus 1. Set that equal to 0. X equals 1. So for my hole, it's at 1 comma something. My hole is at 1 something. To find the something now I'm just going to take this x, like I put it in the table, like a 1 right here, and plug it back in right here to find the y. So y equals 1 plus 1, which is 2. So my hole is at 1, 2. So over 1, up 2. And I'm literally going to do an open circle like a hole. Now, I already know that this is a line, and my slope is 1 over 1. So up 1 over 1, 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 down 1, back 1, down 1, back 1, down 1, back 1. This is just a line, and I'm going to jump over the hole. It's a line with a hole in it. As x approaches infinity and as x approaches negative infinity, f of x approaches Okay, I'm gonna have to look at my graph. Guys, as my x's are getting bigger, where are my y values going towards? Positive infinity. What about down here? Negative infinity. Okay. Okay, and domain, normally the domain of a line is negative infinity to positive infinity. But what do I have to jump over? I have to jump over 1. I got to jump over the hole. It doesn't exist at the hole. A hole is where there's a break in the graph. So negative infinity to 1 and 1 to infinity. And then for my range, I got to jump over the hole, which is at the y coordinate of 2. So negative infinity to 2 and 2 to infinity. Okay, I want to show you what the hole looks like. Okay, so I have this typed in. I'm going to bring it over there so you can see it. Okay, so this is x squared minus 1 over x minus 1. This is the original function plugged in and graphed. Okay, and we said we think that there's a hole at 1, 2, which is right here. So I'm going to zoom way in on Desmos, and I'm zoomed like way in to be able to see it. But this is what it looks like on the graph. It's literally a break in the graph. It's a spot where the graph doesn't exist. You can look at the table and look what the table says at 1 for the y coordinate. It says undefined because there's a hole in the graph. Okay, the graph does not exist at the hole. All right, I'm going to do one more. I'm going to zoom through number 5 real quick. We're going to find all this stuff. First thing I need to do is simplify. I think this bottom factors, 2 numbers that multiply to 20 and add to 9. 5 and 4. Okay, so I'm going to not put those right there. I'm going to come over here. X plus 5 over x plus 5 and x plus 4. Okay, so then my x plus 5's cancel. Ding, ding, ding. There's going to be a hole. Okay, be really careful, guys. Where's the x plus 4 left at? It's in the bottom. So what's in my numerator? A 1. Good. Remember, those always cancel with a 1. Okay, so my simplified function is f of x equals 1 over x plus 4. Okay, so this is what I'm going to use. This is what I'm going to look at. This is what I'm going to do as I go through my steps. I'll get me a table over here. And I'm ready to go. Okay, to find the x-intercept, I set the numerator equal to 0. My numerator is a 1. Set that equal to 0. That doesn't make any sense, so this is a none. No x-intercept means there's probably an asymptote right there. To find the y-intercept, I replace the x with a 0. Okay, it's like I'm plugging in a 0 in right here in my table. So y equals 1 over 0 plus 4 is 1/4. So 0, 1/4. So over 0 up 1/4 is my y-intercept. To find the vertical asymptote, I set the denominator equal to 0. So if you don't have this in the denominator, this is going to throw off the whole thing. So make sure you leave this guy in the denominator. So x plus 4 equals 0. X equals negative 4 is my vertical asymptote. Okay. Horizontal or slant asymptote. So I need to look at my exponents. This is x to the first. The bottom is a 2. Am I bigger on top or bigger on bottom, or are they the same? Bigger on where? Bigger on bottom. Top is a 1, bottom is a 2. Or here, if you look at this one, top is a 0, bottom is a 1. So I'm bigger on bottom, which is 0. So y equals 0 is my horizontal asymptote. I knew that was probably going to happen because I didn't get an x-intercept. All right, I don't have very much happening here. I think I need to get some more points so I can even see what's going on. I think I'm going to plug in, I don't know, let's plug in like negative 2. And I'm definitely going to my simplified function. 1 over negative 2 plus 4. That's 1/2. That was easy. Negative 2 and then up a half. Let's plug in negative 3. Negative 3 plus 4 is 1. So this is 1 over 1, which is 1. So negative 3, 1. You can definitely see this guy comes around like this, and he's really super close to the axis there on my corner. I'm not going to plug in negative 4 because that's an asymptote. But what about negative 5? Negative 5 plus 4 is negative 1. So 1 over negative 1. So that guy's right here. Negative 6 is negative a half. So this one. So it's coming across around like this. Definitely use your simplified function when you're plugging those points back in. It's 1,000 times easier than trying to plug them back into that top one. Oh, I got to find my hole though. Didn't find my hole. I went straight to doing in behavior. Okay, did I cancel something out? What did I cancel out? X plus 5. So x plus 5 equals 0. I set what I canceled out equal to 0. So x equals negative 5. Oh, that's going to be where my hole is. Negative 5. I get y equals 1 over negative 5 plus 4, which is 1 over negative 1. So we already know that's negative 1. I already found it. I got to go back here and fix this. This is where my hole is. Guys, let me give you a hint about your hole. Your hole will always, always, always be in the line of the graph. If you find this hole and it's like way out here somewhere, you didn't find the right hole. Okay? It's always going to be in the line of the graph. It is a break in the graph. So it has to be on the graph. Okay, end behaviors. As x approaches infinity and negative infinity, what is the y approaching on both ends? Yeah, there's a horizontal asymptote. That's super easy. Okay, we have to be really careful about our domain. Domain and range is where we're at here. We have to be really careful about our domain. What are the x values I'm going to have to exclude? Negative 5, because that's where my hole is. Good. And negative 4, because that's where my asymptote is. So when I go to write my domain, I'm going to have to go smallest to biggest and take out negative 4 and negative 5. So negative infinity up to negative 5. And then I can go in between there because I see there's x values right here in between them. So negative 5 to negative 4. And then I can go from negative 4 all the way up to positive infinity. Okay, how about my range? For my y values, everything but where? Negative 1, because that's where my hole is, and 0, because that's where my asymptote is. So I have to go negative infinity to negative 1. Between negative 1 and 0 is fine. And then 0 all the way to positive infinity. Okay, now what we didn't do any of today are slant asymptotes. And so we'll do that one.